This video will demonstrate how to design a double angle welded connection in VAConnect. Let's get started. In this example, we will design double angles welded at both the beam and the column to connect the web of a W16 by 36 to the flange of a W14 by 90 as shown in the detail. This connection will be designed to resist shear force from both dead and live loads. Note, double angle welded connections can only be designed to resist shear loads. According to Part 12 of the AISC Steel Construction Manual, double angle connections with welds on the outstanding legs provide minimal strength to resist axial loads due to the flexural loading that is applied about the longitudinal axis of these welds. Double angle welded connections in VAConnect are designed according to the AISC 360 design specification and Part 10 of the AISC Steel Construction Manual. Both the welds at the support and the welds at the beam are designed to resist eccentric shear loading using the instantaneous center of rotation method to determine the eccentric weld group capacity. The C coefficients for eccentrically loaded weld groups are included in the detailed reports. We will start out in VAConnect by adjusting the geometry of the connection. Selecting the beam, a W16 by 36 will be chosen from the shape database. Next, we will adjust the thickness of the support to equal the flange thickness of the W14 by 90 column. Selecting the double angles shows that two 4 by 3.5 by 1/4 inch angles that have a length of 6 inches are used by default. Now we can move on to applying load to the connection. We will enter values for shear in the dead load case and the live load case. With the service level loads defined, we can go to the load case manager and select which building code we want to use for the load combinations, which are automatically implemented. Now with the loads and load combinations specified for the connection, we can turn our attention to the project status to see all of the limit states that are automatically checked. Immediately, we see that several limit states are failing. The double angles are failing in shear yield and shear rupture. Additionally, we have both weld and base metal checks that are failing. First thing we'll do is increase the length of the double angles. This resolves the various failing limit states for the double angles. Now, only the welds and the double angle base metal check at the support are failing. Clicking on the fillet weld check at the support, we see that the eccentricity on the welds is 4 inches, which is the angle leg length at the support. Reducing the leg length should reduce the demand on the welds to the support. If we reduce the leg length to a value less than 3 inches, the connection detailing fails since we are less than the 3-inch limit, as discussed in Part 10 of the AISC manual. Also, we cannot increase the weld size from 3/16 of an inch without exceeding the weld size limitation in the AISC 360 design specification. Therefore, let's choose the option to weld the bottom of the angles, which increases the capacity enough to allow the weld and base metal check to pass. Note, while VAConnect allows welding along the bottom of the double angles, it does not allow for welding along the top, as this would inhibit the flexibility and necessary end rotation for the connection. Now, all of the active limit states for the connection pass, and we have no detailing warnings, meaning that the connection is adequate to support the applied loads. Note, the flexural yield buckling limit state and the flexural rupture limit state for both the double angles are currently checked because eccentricity on the beam side of the connection is always considered. The unity value for these checks are small since we only have a 1/2 inch offset from the web of the beam to the support. If the angles had larger legs on the beam side and the beam had a larger offset, the flexural limit states for the angles would increase. The flexural demand for this connection is also accounted for in the interaction limit states, which considers combined shear and flexural loads on the legs of the double angle that are connected to the beam. VAConnect also allows for one or both of the flanges of the supported beam to be coped if, for example, we want to accommodate an all-welded double angle beam to girder connection as shown in this detail. The specifics of cope beams are discussed in more detail towards the end of the shear tab training video. With the design complete, we can switch to the report view to easily create a report to document our work. A concise design summary is automatically generated showing the maximum demand to capacity ratio or unity value for each limit state. Also, information on the model and loads can be included in the report. Detailed reports that show the calculations for each limit state can be added to the report. Also, summary tables for each limit state can be included in the report to show the values of the various parameters for the limit state and to show the unity value for each load set and load combination. In just a few minutes, we have used VAConnect to create an optimal design for our double angle welded connection and produce a report to document our work. Thanks for watching and have a great day.